friends. Just kidding. Just waiting for the timer to start. All right, recording has started. Here we go, bell work. We have find the exact value of the sine of negative pi over 12. So I'm just going to quickly go over this. Let me just cover stuff I had. All right, so there is a star. A star must mean important. Important because this is actually TGA question number... I don't know. It's one of the three. I don't remember which one it was. It's 1, 2, or 3. And this is actually the question. This question is from last year's test. I'm choosing this question just to go over this exact question because, well, one, when I Googled this question, it was all over the internet, and I do my very best to report these questions, to remove them. But honestly, there were so many, I couldn't remove them all. So I'm just going to go over this problem, and then your TGA will be a different problem. So find the exact value. The purpose of this one is not use your calculator, use the unit circle, and then use what we learned in 4.02 day 2. So the first thing we want to do is probably convert those radians into degrees. That way we can see it's negative 15 degrees. And then from here, you want to look at the unit circle and think of, okay, well, which degrees, when I subtract them, will give me negative 15. And you actually have quite a few options. So I only showed quadrant 1 of the unit circle because, well, we can actually get that combination. But you can use the whole unit circle to find that combo. And you could do 45 minus 30. We could do 60 minus 45. So in quadrant 1, we actually have 2 choices here. I just went with the first 2. I went with 30 degrees minus 45 degrees. So this is what we have to do first. And then I just put it back into radians. 30 degrees is pi over 6, and then 45 is pi over 4. So now I'm just going to rewrite negative pi over 12 as sine of pi over 6 minus pi over 4. So there's really the first part of this problem. Any questions so far? And again, this should be review from 4.02. If your screen is kind of messed up, let me go forward and backwards and hopefully reset those boxes if it's messed up. Yep, new row. Features, right? Features.
Like accidentally scribbled all over the screen because I was trying to take a screenshot and accidentally clicked inside of it, and then it wouldn't go away, and I kept hitting undo and it wouldn't go away.
Yep, we couldn't see him. All right, so next we are going to use this identity from your sheet, also from 4.02. And we're going to expand this sine of that stuff into, well, sine alpha times cosine beta plus cosine alpha times sine beta. And based on how we have it set up here, alpha is pi over 6, beta is pi over 4. And if you notice, it's plus over minus. And because we are doing minus, we are doing the bottom operator. So in the expansion, we are also using the bottom operator. So also happens to be a minus. So make sure you're careful on your TGA because, you know, I may not give you sine. It could be like, I don't know, cosine, hint, and the cosine identity is flip-flopped from one to the other. So just take note of that. All right, we then look at our unit circle. We find the sine of alpha. Well, let's first set it up. That's what I did. We first set it up. So I just, you know, plug in what alpha and beta are into the formula. And now we just go through, okay, remember, sine is y, cosine is x. We all know that by now. That's if you're actually keeping up to date and going live sessions or watching recorded sessions, you should know this, the back of your hand. All right, so sine is y. So, well, what's the y value at pi over 6? Well, the y value is 1 over 2. Cosine, that's the x value at pi over 4. Well, that value is rad 2 over 2 minus cosine. So the x value at pi over 6, that's going to be rad 3 over 2. And then sine is y. The y value at pi over 4 gives us this. So it's just, picking right from the unit circle. None of this stuff we will be typing in. The only thing you use your calculator for in this problem would be, my mouse is so laggy today. Maybe this part right here when converting from radians to degrees, so we can see this number to, find the 2 degrees that are on the unit circle. But that's really the only time we're going to use the calculator. On your TGA, I would everything that you see on my screen right now, well, minus the unit circle, I would expect to see for your work on the TGA if you want credit. If you go right from the question to like the answer, you're getting 0 points because you obviously probably just typed it in. I need to see these steps if you want credit. No shortcuts. So everything I'm showing here, that's enough steps. All right. 1/2 times rad 2 over 2, that is just rad 2 over 4. Rad 3 over 2 times rad 2 over 2 is rad 6 over 4. And then for the final answer, we need to write it as a single fraction. So if you notice here, they're both over 4. So, well, that's the common. So we just combine the numerator. So we have rad 2 minus rad 6. Those are not like terms. We cannot combine them. So we write it just like that. And we're done. So your TGA, one of the problems will be similar to this problem. And that's why I have the star in the top right-hand corner. It's important. So I just thought I'd go over this problem with all of you. I will go over another TGA problem on bell work later next week too. Well, it's easy when someone goes through the proper steps, then it makes sense, right? But then if it's blank and then you're asked to do it, you're like, where do I start? What's going on? What's 1 plus 2? All right. Anyway. All right. Day 2 of 4.05. Day 3 is on Monday. Law of cosines. We're going to find the missing side lengths and angle measures of triangles using the law of cosines. All right, being recorded. All right, slide 4 of 9. All right, so here's the law of cosines, and all of you should have this on your printed identity document that all of you downloaded off the course homepage. So no need to snip it. All right. So these are the 3 variations, and really they're the same. They're just talking about, if your point of view is angle A or angle B or angle C. So something to take note, if you're using angle A, side A is on this side of the equal sign. And that goes for, you can see angle B, side B on the other side, angle C, side C. And then, so here's angle A. Side B and side C are on the same side as this. So yeah, you can kind of see the pattern and how they construct the other two. So really, these other 2 equations, they're not different. They're just looking at a different angle, so it just looks different, but it's basically the same equation. Remember, big letter A, angle, lowercase a, side, just like yesterday. All right, so finding the side. So we want to find the length of side DE. So that would be from here to here. We want to round to the nearest hundredth. So I'm just going to put, I think I call this X in my work. I don't know. But if you notice, I don't have them labeled ABC. If you want to relabel them as ABC, just so it's easy to kind of pick out the right ones, you can. I didn't. So I listed the formula, and we're just going to plug stuff in. So we're trying to find my X that I labeled. So we're going to have x squared. Well, actually, I do call it a. Let me just rename that a just so I'm consistent. Which means this is side A, right, or angle A. If you're looking at the formula. All right. So we have a squared. So B and C, it doesn't matter if 17 is B or 15 is B. It doesn't matter. I don't know what I did. I think I chose 15. We got 15 squared, 17 squared. So these numbers, when looking at this angle here, these numbers are going to be the ones that are touching, the sides that are touching that angle, the adjacent sides, 15 and 17. And once you do this a few times, you kind of see that pattern. It's pretty easy to remember it. Minus 2 times, well, B times C. And then cosine of A, we know, is 58 degrees. So there's the setup. All right, next we are going to do, well, just remember, we're solving for A, so we're going to do the square root of both sides. Well, remember, this is lengths, so it's not plus or minus. Length is always positive, so that's why it's only positive and not plus or minus. All right, so everyone on your calculator, type that entire thing in. Radical of all that stuff, ready to go. And tell me what you get rounded to the nearest hundredths. All right, so we got some answers. Let's see. Number S. What are you talking about, number S? So 15.61, 16.61. Oh, 15. Okay, that's what you meant. 21.29, 15.61, 21.29, 15.61. So, one thing I want to point out, you really, when doing trig, you really got to be careful of the problem you're doing, and because we could be in radian mode or in degree mode, and this one we are obviously need to be in degree mode because, well, the angles are in degrees. So, always check. From problem to problem, it may change. So you got to be super careful on your test. So we should be in degree mode. Don't use Symbolab. I really don't think you should use Symbolab. Based on what happened yesterday when typing something basic, it didn't work. And I really don't know why it didn't work. It was so wrong. It was sad. Don't use Symbolab. I don't approve. I approve more of an Apple calculator than a Symbol calculator. That's saying a lot. All right, so I think the answer is that one that most people got. 15.61. No, he'll watch the recording and he'll like snip that part. And then he'll edit it so it'll say like I approve of the Apple calculator. All right. So people who did not get, when they type it in, didn't get 15.61, are you retyping it in to make sure that you can get this? Because I would say this is like the hardest part of this problem, I think, is really probably typing it in. All right. Everyone good on getting that answer? from your calculator. Okay, good, good, good. I know, understanding stuff always makes me feel good too, right? So I can totally relate. I like these because you understand them. Ever try to do something, whether it's a lesson or something you're working on, and you just can't understand it, and you get so frustrated, you just drop everything and just walk away, or that too. Yeah, if it's high stakes, yeah, I understand. Okay, everyone, try this one. I think I'm gonna give you. How about 3 minutes? I think that's more than enough. Oops. So we'll do 3 minutes, and then I will put one of those surveys on the screen here. So just give me a. So don't put an X yet. Just when the time's up. Actually, I'll do now. All right. When you are done with the problem, give me a green check. So don't click the X. When you are done, give me a green check mark. Naya, what's the X for? Oh yeah, guys, feel free to jump on mic whenever you want to ask questions. I don't always see chat. All right, so time is up. Um, so you put RT in the question with a bar over it, but shouldn't it be RT without a bar? Um, so RT with the bar above it means the line segment. Um, so why are you saying it's without the bar? All right. And if you're not done with this problem, give me an X so I know you're here. If you're not done, just give me an X because I want to make sure people are actually like actively here and working on these problems. All right. So everyone answered except me, of course. RT with a bar over it is the same. Um, is the name of the segment. So RT with the bar over it is the name of the segment. Is that true, Chloe? Is with the bar over it just the name of the segment? I don't think I've ever heard of that. RT without the bar is the length of the segment. Really? I'm gonna fact check you. You know, I haven't taught geometry since 2000 uh since like 2010 or 11. It's been a while. So I'm gonna double check that. You might be right. It doesn't sound familiar to me. All right, Chloe. I'm gonna say you're probably right, and I'm probably wrong. But well, look, we'll see who's right. Can anybody else confirm what Chloe's saying? The bar over is the name, and then without the bar is the length. No one else knows. No one wants to take sides here. Okay, it is just the name. Okay, well I will double check. I didn't know that if that's true. It's like a label. Oh, I always thought. Yeah, I don't know. I'll look. Okay, I will look. I always thought it being the length of segment RT. So like without arrows, it's a segment. If there's one arrow, it would be the ray. If it's double arrow, it would be a line. But I'll look. All right. So I saw people put the answer in chat. Looks like 27.22. Quiet dog. All right, 27.22. 1.819. Let's see. So let's see. Julia, you got a different answer. Let's see if your setup is the same as most of ours. That's what you should have had. And that's what you should have typed in. Right. Yeah, there's so much to type in. You really got to make sure that it's accurate. Because your work could be great, but then when you actually type it in, you might, I don't know, forget something or mistype something. It changes everything. All right, Julia, what calculator are you using? Using Chrome. Does Chrome allow you to enter everything at once? Okay. You have a link to the Chrome calculator so I can take a look at it? I'm curious. All right, I'm checking it out. Oh, yeah. So this one, you have to be super careful with parentheses. Yeah. So let me. Dun, dun, dun. Let me quick. I'm going to type this in. Oops. Root of 19.5 squared. My answer wasn't even close either. I got 37.9 when I used Chrome. 19.5 squared plus 21.1 squared minus 2 times 19.5 times 21.1 times cosine 84.1. Am I in degree mode? Oh, I'm not. I'm in radian mode. Let's fix that. All right, I got 27.22 that time. Yep. So I was able to get the answer. And Julia, that's what I typed into Google Chrome calculator. So you got to be careful on Google Chrome. I noticed that if you type in COS, right when you type in C, it puts cosine and then O does nothing. But then if you hit S, it'll put sine right after cosine. So maybe you did the cosine of sine of 84.1. Julia, what do you think? Good? Bad? What's going on? So it sounds like you're just typing it wrong. So you really gotta look to see where you mistyped it. Yeah, um, go mow someone's lawn and make $12 to buy this calculator. It's FX, whatever it's called. Oh boy. Julie can do all this math, but she can't type it in. Fails the test. Life is over. Dun dun dun. All right. Let's get. We got 20 minutes left. Let's get through these last three problems. Oh, two problems. Sorry, got two problems left. All right. So now this one, we're trying to find the angle, not the side. So this triangle, I have it A, B, and C. So we want to find the measure of angle C. So we want to use, so I'm going to circle our angle we're trying to find. So this is our point of view is what we're looking at here. All right, so because we're trying to find this angle, I definitely want to, well, have angle C here. So in the law of cosines, you're only going to use one angle, and in this case, well, it's the angle we're trying to solve for. All right, you're given all three sides. So angle C is here. Side C is on this side. So well, there's your 24. So 24 squared will go here. So everyone go ahead and set up your equation. I'll just give you 30 seconds to set up the equation. Let's compare and see if what I have and what you have match. Thirty seconds. Oh, he's here. Five seconds left. All right, it's quite a bit to type out in chat, so let's just take a look and see if we get the same answers. Setup. Remember, A and B, those, that doesn't, well, actually does matter in this case because they're actually labeled properly. So yeah, A is, so yeah, what you have written, what I have enter should be exact. No difference. Everyone doing good? All right, all right. So we're trying to solve for, well, angle C. So what's our next step here? What's the next step? So if you're trying to solve this all by yourself, what should we do next? Simplify all this stuff. So you got to be careful if you simplify. Like if you type in what 24 squared is, what 13 squared is, what 30 squared is, what happens is you get really big numbers, and just writing those out can be, could get you into trouble in the sense that what if you just copy them from your screen to the paper, or when you keep going with your work, typing all those numbers in from the paper to your screen. Um, I would personally hold off on simplifying those squares to combine, like terms. You absolutely can, but numbers can get pretty big. And we can get to the answer by just leaving them in that form, but it's really your choice. So Antonio just showed up, says we can move the slides back, and I don't know, slides. I think it's sides.
No,
The
my
sides.
okay. You know when you make the screen full screen and it messes up your whole entire thing? Thank you.
You're welcome. Okay, so Caitlin says she subtracted 13 power of 2 and 30 power of 2 from both sides. Yes, and I think that is excellent. I think that's what I did also. I subtracted both of those from both sides, and you got to be careful. So if you notice, I put them in parentheses. I would recommend doing the exact same thing, because when you type this stuff in, if you type in without parentheses, depending which model calculator you have, it might think you mean to do negative 13 squared and not just 13 squared. And there is a huge difference. So make sure you put it in parentheses just to be safe. And sorry. All right. Next, what do I do? So we can't do inverse cosine because it's not by itself. You have stuff multiplied in front of it. So what Caitlin says, you want to divide by that stuff. Yep. Divide by that stuff. Okay, Antonio, now what do we do? I know you want to say it. Now we can inverse or arc sine both sides. Yes. So arc sine of that stuff. So enter what you see on the screen in your calculator and hit enter. Make sure you are in degree mode, because we want the answer in degrees, not radians. So if you're somebody who decided to type in 24 squared and 13 squared and 30 squared, and then you combine this, so then you have one big number in the numerator. Then on the bottom, you could have done negative 2 times 13 times 30 and also have a relatively large number 2. And your answer should be the same as long as you didn't copy something wrong. So it's really up to you. All right, what did everyone get for your answer? So we got somebody says 50.81, 50.80, 50.8. So, well, let's look at rounding. Sarah, on mic, can you tell me your decimal to like 6 places so I can write it down?
Yeah, so it's 50 decimal 798 37493.
Okay, that's plenty. Thank you. All right, so let's talk about rounding. So, a lot of people actually have trouble rounding. It's maybe because you weren't taught correctly. So the nearest hundredths is 2 places. So again, this is how I taught it. We draw a vertical line here to separate, what we want 2 places, and then we look only at this one. We don't care what is after that 8. It could be like 8,99999. It doesn't matter. We only care about that number after that vertical line that I drew to separate it, and we ask ourselves, is that a 5 or higher? Question mark. And the answer is yes. So if the answer is yes, well, then all we do is add 1 here, and 9 plus 1 is 10. Carry the 1. 7 plus 1 is 8, and then everything else just drops down. So that is rounding in a nutshell. I should have. Yeah, there you go. And that is the answer. So 50.80 or 50.8, same thing. I think when you enter this stuff into like quizzes or tests, because it's hundredths, the system wants you to actually write the 50.80. But 50.8 is actually, in my opinion, more correct, because we all learn in grade school that after the decimal place, if you have just ending trailing zeros, you don't put them. And that is true. 50.8 is the answer. So you have to zero at, not understanding your question, Zoe. Oh, you have to put 0 at the end because it's the hundredths place, right? So Chloe, yes, only because the grading system that I have no control over whatsoever wants to see 2 places. So they want to see that 0 when you enter it. I don't agree with it, but I can't change it either. So 50.8 is actually the correct answer. Now, on a test or a quiz, if you the answer was 50.8 and it marked it wrong because it wanted to see the hundredths place written out, I would just manually give you the points. And I've done that before to questions that people put the negative sign in on top instead of in front or whatever. Yeah. Yeah. 50.8 is correct. All right. Last example. All right. I'm going to give you all 3 minutes to solve this. Ready, go. It's gross. Oh, that's sad. Do you have your dog on insulin? Take his blood sugar once, maybe twice a day. Been pretty steady. Yeah. So if your dog ever, this is going off topic a little bit. So if you don't check your animal's blood sugar because it's been stable, so you know, but if your dog ever kind of like goes into like basically laying there mode and possibly seizing, maybe, um, more than likely the blood sugar is way too low. And what you got to do is hopefully you have a bottle of like high fructose syrup in your cabinet, and you want to basically shove fructose syrup like in its mouth, gums, not like down its throat, but put some and rub it in his mouth so they can eat that to bring the sugar up quickly as possible, and obviously take it to the vet. But yeah, for people, when that happens, kind of similar effects. They kind of go comatose, and drinking orange juice or having a Snickers or something can bring that sugar up if it's dangerously low. And I believe dangerously low would be like for people below 60, I think. Yeah, I think that's right. All right, so we got 17 seconds left. I'm going to give you a little survey. So give me a green check if you are done. Give me X if you are not done. I want to see who's here and who's not here. Okay, so if you are done, green check. If you are not done, give me an X. Do all of you need a little bit more time to type it in? Is that what's going on? All right. How much more time do you guys need, people who are still working? Okay, we'll do, how about 1 minute more? 1 minute, and then we'll check for answers. So 1 minute to finish up. All right, time is up. So in chat, go ahead and write down your final answer. Let's see what we get. 73.65. 61.18. 61 so we're kind of torn between 73.65 and 61.18. Well, let's take a look. So we got two answers for torn between for some people. I got 73.65. So if you got 61.18, let's just look at what you typed in. So if you're using an FX calculator, you can hit the up arrow and it goes back to what you typed in. You can edit it and take a look at it. So here's the setup everyone should have had. So one thing I like to do is circle. So we're trying to find angle Z. So that's this one right here. And opposite that would be, well, little z. So that's why 23 is on the other side of the equal sign. It does matter. Oops, let me finish up. Get that file for you too, Chloe. Or it's the second one. Oh, okay. You just forgot to type something in. Well, that makes sense. That makes sense. All right. Final thoughts. All right. So sine versus cosine. So exactly what this says. So we want to use a law of sines when you have two angles and a side. Or, okay, well, that's a typo. I put number 2 and I typed 2. Or you have two sides and an angle. We want to use the law of cosines when we have an angle with two adjacent, also known as touching sides, right, to that angle, or we only have three sides and no angles. So those are the scenarios you would want to use one versus the other. Well, there you go. Well, guys, thanks for coming. And as always, I hope you learned something.
Would you mind if I go through the slides real quick?
Sure.